What's up, guys? Today I'm going to teach you how to solve the crazy 3x3. Now before we start, there's two things I want to let you know. One being that there's going to be timestamps down in the description, just in case you want to jump around to each step. And secondly being that you do need to know how to solve a 3x3, a normal 3x3 Rubik's Cube before you solve this. But with that being said, let's jump right into it. Now before we start solving, I want to show you how the crazy 3x3, how it actually works. It's what makes it different than a normal 3x3. So if you're turning like along a side this way, if you look on the layer on the side, nothing is going to look different. Sure, there's going to be that extra piece in there on those middle edge pieces, but they're not seemingly affected by anything at all. The difference comes in when you start to turn a face on its front. So watch when I turn this side this way, notice what happens to the outer pieces and what happens to the inner pieces. If you see, the outer pieces are turning, but the inner pieces stay in place. So this is the main issue and difficulty with the crazy 3x3. Okay, step one is not actually that bad. We're just going to solve the cube like a normal 3x3. However, we're going to ignore all these tiny baby pieces in the middle. Whatever they're called, these tiny baby pieces, we're just going to ignore it. So we're going to solve it like a normal 3x3, but because we're ignoring the baby pieces, we're only really caring about these small pieces on the edges. So when we complete this step, it's going to look something like this. As you can see, all of our outer pieces are done, and we just have a bunch of random scattered baby middle pieces unsolved. So if you reach this point, you are in a perfectly amazing place. If you're struggling to get to this point, struggling to solve it like a normal 3x3, just if you want to, you could hide these like baby inner pieces with your fingers to really see what the piece actually is that you're trying to solve like a normal 3x3. And you could just keep going like that. Eventually, you should be able to get the outer pieces solved like a normal 3x3. Now, I solved the cube here, and I did that so I could show you our pretty much three main algorithms we're going to use. So I'm going to show them to you on a solve cube so you can see what they do. So the first one is called a T-perm, and it's going to look like this. If you know how to read Rubik's Cube notation, it will be up at the top here. We're going to do right side up, top this way, right side down, top back. Right side down, front down, right side up twice, top this way, right side down, top this way, right side up, top this way, right side down, and front up. So the important thing is actually that we do this thing twice. So I'm going to do that again really fast. So once we do this algorithm twice, let's see what happens. If we look in the top layer, all of these baby middle pieces, they swap to the opposite side of the cube. So green is opposite of blue, and this baby blue is on the opposite side. It's on the whole green side instead. If we're looking at red and orange, these are opposites. They swapped opposite as well. So doing what we call a T-perm twice is going to swap these middle pieces in the top. All four of them, it's going to swap them to the opposite side of the cube. So the next two algorithms we're going to learn are both called U-perms, and one is going to be from the right side, one is going to be from the left side. And they're basically mirror versions of one another, but it's very important that we know both of them in order to solve the cube. So, again, there's going to be Rubik's Cube notation in the top if you know how to read it, but otherwise just follow what my hands do. So we're going to start doing right side up, top this way, 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 right side down, top this way, and right side down twice. Now the important thing is that we have to do this 3 times total, so I'm going to do it 2 more times, then I'll be back with you. Okay, now that we've done that, it doesn't look like anything special happened. It looks like we just screwed up a lot of the pieces on the cube. But there's actually, we actually did do something, it's just harder to see. What we did is that all of the pieces in the top layer, all the baby pieces, they shifted to the left by 1. So this green, so this was the big green side, so there was originally a baby green piece here. Now it's on the left side. There's originally a baby orange piece here. Now it's on the left side here. Originally a baby blue piece here. Now it's over here. Originally a baby red piece here. Now it's over here. So all the baby pieces in the top layer, they switch to the left by 1. And if we look all of the baby pieces in the right layer, all of these shifted down by 1. The white went to the front. The green went to the bottom. The yellow went to the back. And the blue went to the top. Now remember, I did say there was a mirrored left side version, so this is what that one looks like. We're going to do left side up, top this way. Left side up, top this way. Left side up, top this way. left side up, top this way, left side down, top this way, and left side down twice. And again, we're going to do this one 3 times total, so I'm going to do it 2 more times. And then when we're done with that, it looks like this. And again, it looks like a bunch of nothing happened, but it's basically the same thing mirrored on the left side. So now all the things on the left side are the ones that shifted down 1, and rather than all the things in the top layer shifting to the left 1, they actually shifted to the right 1. Okay, so in knowing those 3 algorithms, some of you could probably leave right now and then go figure it out with just those 3. And if you can, just be my guest. Go right ahead. More power to you. But I'm just going to show you guys a small method to actually do the rest of the pieces should you want to use it. Now, the first thing we want to do here is what we're going to do is we're going to be solving all the pieces we can using the algorithm from the right side. So remember that algorithm from the right side, what it did was all the baby pieces in the right layer, they shift down 1, and all the baby pieces in the top layer shift to the left 1. So because it affects two layers, all we're going to care about is trying to solve one of these layers using this thing. And that layer is specifically going to be the right layer. So what we're going to do is we're going to look around the cube and look at how the pieces are getting affected. And we're going to see which right layer pieces can get solved using this algorithm. So because the right layer pieces solve pieces by making them go down 1, we're going to look for pieces in right layers, depending on how we're holding it, that can be solved by going down 1. So if we looked over here, this is already solved. Yellow solved, red solved, so we don't want to care about this one. And if we were to look over here, we have white goes down 1, it matches with white. Blue goes down 1, matches with yellow. So this is good right here. This, if we shift all the right pieces down 1, they will get solved, so that's a good thing. However, even though we're only caring about solving the pieces on the right, we don't want to just mindlessly start doing this algorithm because it might mess up some pieces in the top layer. So we do know that while it solves the pieces on the right, it also shifts all the baby pieces in the top layer to the left. So what we want to do is we want to make sure that our baby top layer pieces are going to be a layer that has pieces currently unsolved. So right here, this white matches white, red matches red, orange matches orange, yellow matches yellow matches yellow. So everything in the top layer here, all these baby pieces are solved. So if we were to do the algorithm from this position, it would mess all these up and that's bad. However, we can actually rotate the cube because it's still affecting the right layer. So if we just rotate the cube up or down, it's still affecting the right layer, but it changes the top layer pieces that get affected. And now we can see that these are unsolved. So when we do the algorithm, these might get solved, these might get more unsolved, but all that matters is that they're not affecting any currently solved pieces, so we are perfectly fine doing the algorithm from this spot. So again, I'm going to walk through the right algorithm right here for you guys real quick, but again, there will also be that Rubik's Cube notation in the top. So it's going to be right side up, top this way, 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 right side down, top this way, right side down twice. And then we do that 3 times. And now if we look, all of these pieces in the right layer are solved now. So basically we're going to repeat that kind of process over and over again until no matter how much you rotate the cube, you cannot find any more pieces that where the right side moving down those baby pieces by 1 will solve more pieces. Once we hit this point, we're going to move to doing the same thing on the left side. We're going to use that left algorithm and find the left pieces that could be moved down 1 to be solved. So I'm going to look around my cube and I found one right here. Move this red down 1, we match with the red, white down, we match with the white, orange down, we match with the orange, and it just keeps going. However, we also still have to make sure, because not only does it move the left side pieces down this way by 1, it also moves the top layer pieces to the right by 1. So if I was to do it in this, holding it in this orientation, whatever, yes, it will move the left pieces down 1 and solve them, but it will mess up these solved top layer pieces. So let's just move the cube down like this by once and see how this does. The left pieces are still fine, and these top pieces are currently unsolved, so it's completely fine to do it here. So I'm going to show you how it works again, because it's the left algorithm this time. So it's going to look like this. Left side up, top this way, 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 left side down, top this way, and left side down twice. And remember, we have to repeat this to a total of 3 times, so 2 more times. Now that I've done that, we can look around and see that all these pieces on the left are done now, and these top pieces are still unsolved, which is fine because they weren't solved in the first place, so it doesn't matter that they're still unsolved. So you're just going to repeat that process. You might have to switch between doing some of the right side algorithm and then the left side algorithm, depending on how your cube is scrambled, but eventually you'll reach a point where you look and you can't do anything with the right side or the left side. And when this happens, you might also notice that all that's left is the pieces where they're swapped on the opposite sides. And if you remember, we do have an algorithm for that. So we're just going to do that here. We're going to look for double swapped pieces, hold them in our top layer, and we're going to do that double swap algorithm twice. So we're going to do right side up, top this way, right side down, top back, right side down, front down, right side up twice, top this way, right side down, top this way, right side up, top this way, right side down, and front up. Remember, we do it twice, so I'll do it one more time for you guys. And then now if we look, all of these pieces in the top layer are finished. So once you go through those 3 processes, you might have to do it a few more times, but with that, your cube should be solved. Thank you guys so much for watching this tutorial. If you found it helpful, please be sure to like, comment, and subscribe. And check out this playlist that's about to pop up, and you could find all my other Rubik's Cube tutorials.